one. The one you are on now, that connects sound.
No,
And,
it connects the floppy drive.
floppy.
Yeah.
The small one, yeah.
Yeah. Okay, so this is the birch connector that connects the floppy drive. Okay, so these are the different connectors, and all of them they come provided by the power supply. Okay, now we have the 20 pin to 24 pin slotted connector is the one that connects the power supply to the motherboard, and in addition to the AUX connector, which is 4 pin connector, again it connects the motherboard. Now, before moving away from this part, one more thing I wish to introduce over here is these guys, although they are not going to be part of any of the assessment, but it's always to know, to remember. You remember at school, grade 6 maybe, we took such things, or even before grade 6, we took the voltage, we took the power, we took the current, we took the resistance. For example, the voltage, we all understand that there are electrons that they travel in the wire, and the power used to push those electrons in the wire, it's called the voltage.
Sure.
The current, we all know the current. For example, the resistance, any object that you have something running in it like electron, it is going to oppose that thing, which is called the resistance. Well, as a side effect, the resistance is going to cause a heat. So all this thing, guys, make sure to read them. Okay. You don't need to worry about the numbers and about the conversion, okay, over here, but it's good to read them. Computer components over here, we're going to start introducing computer components, and I usually write them on the whiteboard, all the computer components. I list all of them and explain all of them individually, and later on I come in general. We start talking about the motherboard. Motherboard comes from different form factor. When we say form factor, that's mean the physical properties of that component, and we have different form factors like the ATE. You don't need to know what does it stand for. The ATX, the one that I told you about, mini ATE and micro ATE, LBX and LAX and PTX. Each of them is used in different places, but all of them they have the same concept. For example, for the micro ATX, we use it in small PDAs, or mini ATX, which we use it for laptops. Okay, NLX, it's one used for, or PTX, they're used for laptops. Okay, they're all different motherboards. But they are motherboards and they have different form factors. Motherboards, they share one thing, that they have the CPU installed on it, they have the RAMs installed on them, the expansion slots and expansion ports, cards installed, all of them. So it's just as it sounds, it's the mother that has all the components installed on it. Okay, motherboards that they come for AMD processors, they are different from those who they come for the Intel ones, so you make sure that you're buying the right motherboard and correct motherboard. Later on we'll see the compatibilities issues between the internal components and motherboard. Some motherboard they cannot address more than 4 GB of RAMs, and it should be DDR2. They cannot address DDR3, so it's not a matter of you install something on them, there is a compatibility between them.
Sure.
Okay, now there are CPU types, and CPU they differ in many things. To us, the CPU, they come with different speeds, different frequencies, and different different capabilities, different features. But from now on, we need to understand that CPUs, they come with different bus size, they come with different energy consumption, they come with different socket specification. What is the socket? Let us go to Google. Okay, you notice over here I always use Google to help me, aid me.
As we discussed the other day, Google was the
yeah,
best thing.
yeah, isn't it amazing, man? I need to mention CPU. Okay, this is the socket. This is the socket connector. This is the place where you install your CPU on. In the past we had something called slot connector. This one used to be the slot connector where the old one where you used to insert the CPU as a card. Okay, it used to come installed on a card and you install it, but fortunately we don't have it anymore. Now we have this socket, and this socket is called zero insertion forces, ZIF. That means you simply place the CPU on it and without applying any forces, without pushing your component inside, just like we used to do on the slot. You install it, and we will see this part installation in our lab. Okay, now many instructors, they find memorizing the socket type and the socket size with each of them tricky. Even myself, I don't memorize all of them. I know the famous one for Intel, like the socket 6, and these guys that they are widely used, but I don't remember all of them, honestly. So you need to go through them, such things, guys. What matters to me is the CPU architecture. Over here we're going to introduce two architectures. Mainly these two architectures are used in the market. When we say CPU architecture, guys, we mean the way that CPU handles the instructions and the way that CPU was built on the micro level and on the registers level and on the instructions level. CPUs, once it handles the information, they are not called information, they are called instructions. And let me explain this part over here using Paint. Over here I have a CPU. Okay, this is my CPU over here. Inside the CPU, guys, there are too many components.
Sure.
There are too many components, and there are memories, there are transistors, there are places in the memory and the cache, we call them registers. Okay, they are interconnected to each other using lines. Okay, so CPUs, they handle information that they come from the bus, from over here. CPU is connected to the motherboard with a bus. Whether it is 32-bit architecture or 64-bit architecture. What do we mean with 32-bit architecture and 64-bit architecture? I'll explain it shortly. Let me explain this one. Let's say any bit architecture we have over here. CPU is connected. CPU receives information, receives the input and sends out the output. Now the method that the CPU handles the instruction defines the architecture over here. Instructions, as we said, they are information, but once they reach the CPU, they are already called instructions. And the method of RISC, which is reduced instruction set computer, these instructions are going to be divided into small chunks, small pieces of instructions, but they are going to be handled. They are going to be handled rapidly. Okay, so we do have small pieces of instructions that they come inside the CPU and they are handled. So the information or instructions they are handled in small pieces, in small chunks, and later on they are processed by the CPU. Fine. This is called RISC, and they are processed. Uh, um, rapidly. Coming to the other architecture, which is called complex instruction set computer. In this architecture, we use a broad set of instruction resulting in fewer steps per operation. Okay, whenever you use a broad set of instruction, that leads to fewer steps of operation. What kind of operation or steps we can have at the operation level? For example, you get, let me color it in different color. You get the instructions on the CPU. That instruction is going to be, let's say, pushed inside the register, which is the memory, and later on is going to be read by that CPU from the memory. Later on, the results are going to be pushed back to the memory. So all these things are called steps to execute those information on the CPU. Okay, so this is one architecture we study. I don't want to go more in details. This is a science that they study it. Computer engineer, and people that they are doing their masters in engineering, mainly they're more concerned about this part. So this is what you need to know about this. Okay, the CPU is dual core. For example, over here it has inside two cores that they process information. Each of the cores, they can load balance the resources between them, and they share some common resources, and they have their own dedicated resources like RAMs and cache, and they share some of them again like cache, okay, and registers. So
Yeah.
this is the concept of dual core. Now we have the quad that comes with 4 core, and we do have even 8 cores, which is something great.
Is 8 code already?
Yeah, oh, we do have, look guys, now CPU stands for Central Processing Unit, right, Marlon?
Yeah.
GPU stands for Graphical Processing Unit. GPUs, they have, GPUs, they have, some GPUs, they have already more than 100 cores. Can you imagine? GPUs,
The new one from I think it's from AMD, which is actually CPU and GPU all built in one. It's the first processing unit they made.
I heard about it. It's the
one.
fastest computer in the world, right?
Yes, it is. Yeah, I actually got some email or something, and it was in there, so it was quite interesting. I think they have actually started selling it here. It was about 8,000 dirham or something, but they are selling it here.
Oh, well, that's mean it's a different thing what I'm talking about, because the PC that I'm talking about cost millions of dollars. Okay, that's the
Okay, no.
fastest.
This is something which is actually made by AMD, and they have actually put CPU and GPU all in one, which makes it a lot faster. Picture is a
True.
lot more clear, and obviously the consumption of power is a lot less.
Yeah,
So
yeah.
it's more green.
That's great. Yeah, that's true. I heard that too. And by the way, AMD is the one that used to provide the architecture for Intel, and later on they decided to produce their own CPUs, and they do good stuff. AMD, and AMD is
Sure.
widely used for graphics. Okay,
Sure.
great guys. Obviously, we all know why do we need the fan.